Natalie, and today we'll be doing a demonstration called core reaction. We will need a flask, a stirring rod. You don't need this, but it would be nice to have one. It's a Celsius rod. You could put it next to it while the demonstration is going on. This is the other thermometer that will be telling us how hot it is in the room. This is barium hydroxide. This is ammonium hexanoate and a cardboard. Before the demonstration, we have to dampen this cardboard with cold water. Make a little puddle so we can freeze to it. And set it down, and then we'll start. And then after your gloves, your goggles. Okay, now I will start. It's going to be first 20 of barium hydroxide. You have to get around this same chemical, and do not mix chemicals at home that you have no idea what you're gonna do. You have to mix it slowly so the balance does not get confused, so it won't go over. That is enough. And if there's extra, just put it back, because nothing has mixed with it, so it'll be fine. Boop. Now we are done with barium hydroxide. You will not need this for the rest. Yeah. Okay. Oh, you have to shake this a little because sometimes it gets stuck. And this is perfect. It's kind of like a snow material, but again, it's chemicals, so do not play with them. And it will release gas, so that's why we're using a stopper. We added 10 grams of ammonium, and now we are ready to mix. Use the stirring rod instead of this, the Celsius rod. And here we go. As you can see, the solid is now it will be turning into a liquid, like right over there. See it? Kind of looks like applesauce. And it's going to release some gas, so that's why we have the stopper. That will be enough. Now we're gonna put this here. In about less than 2 minutes, this should freeze. In the room right now, the temperature of the room should be about let's say 20 Celsius. We're gonna leave this here. See if and it should be, it'll go down in a little while, in about 2 minutes. After 2 minutes, we will check our chemical reaction, and right now it's about 313 Celsius. And in the room, it's 20 Celsius. So it's freezing down below the level, and I might be able to pick it up and put it down with this. We also have washed the things we use that involve the chemical touching, because no one wants to get hurt. Okay, so let's see if this will work. As you can see, the water has frozen under it, and it's staying there. And yes, this has not, the solid in there has turned to a liquid. How does it work? It works by the two solids by mixing in the flask. Both solids were melted together to form a liquid. As happening, the temperature of the system is dropping dramatically. It also smells like ammonia. When the flask placed in the water has froze. And see, it stays there no matter what. May move it, but it's still there. The outside of the flask is very cool to the touch. And our thermatic reaction is a reaction that takes in heat, using the heat as a reluctant. Our thermatic reaction, on the other hand, is a reaction to give off the heat. Awesome. I'm from Horizon Science Academy. This is called Cool Math and Science Rocks.